Now we are starting, that is, our lesson is chemical kinetics, right? And this is chemical kinetics, my part 2 video, right? This is chemical kinetic part 2 video. After the part 1 video, I will WhatsApp the notes, all the notes I will send to the group by the images, right? So I will not give the time to write down the notes here because the notes are given by the WhatsApp, right? Okay, now we were discussing about the rate of reaction, right? Then we have the definition for the rate of reaction. The next thing that we are going to discuss, just concern the reaction that I give here. The reaction that I am going to concern in this instance is the reaction that I am going to concern is that two, right, two N2O5 to N2O5 gas. N2O5 is a gas. This N2O5 gas is converted to 4 nitrogen dioxide gas and oxygen gas, right? So we will concern this reaction. What is the reaction that we are concerning? Dinitrogen pentaoxide gas. The dinitrogen pentaoxide gas is decomposed to nitrogen dioxide and oxygen gas like this, right? So when the reaction proceeds, now you can understand that when the reaction proceeds, dinitrogen pentaoxide concentration decreases. So as I said earlier, how fast the dinitrogen pentaoxide concentration decreases, same fast the reaction takes place. Meanwhile, nitrogen dioxide concentration will be increases. How fast the nitrogen dioxide concentration increases, same fast the reaction happens. Oxygen concentration also increases, right? So in this chemical reaction, right, if the chemical reaction takes place like this, right, so this concentration decreases, these two concentration increases, so we can express the rate of reaction respected to dinitrogen pentaoxide or nitrogen dioxide or oxygen concentrations, right? So we can draw a graph to show that how that their concentrations are changed with the time. It's like this. I will draw the graph to show that how their concentrations are changed with the time. This axis will be time, right? This axis will be time, most of time measured in seconds. This axis is the concentration, right? This axis is the concentration, measured in moles per cubic decimeter. So you know the gradient is then the rate of reaction. Now look at here, with the time, what will happen to this nitrogen dioxide? At the beginning, nitrogen dioxide is nil, right? With the time, nitrogen dioxide concentration increase and becomes constant. This is how the concentration of nitrogen dioxide changes with the time, right? Then next one, how the concentration of oxygen change with the time. It will be like this. This is how concentration of oxygen gas change with the time, right? And then how the concentration of that dinitrogen pentaoxide changes with the time. It change like this. Dinitrogen pentaoxide concentration is very high at the beginning because at the beginning only that is there at the beginning. With the time their concentration decrease, and finally it comes to a constant level like this. This is how the concentration of N2O5 gas is changed. Now how do I know that nitrogen dioxide concentration, the curve which represents the nitrogen dioxide, comes well above all the others? How do I know that the yellow color line or the line which represents the concentration of nitrogen dioxide change with the time is coming well above the oxygen? That is because when 2 moles of dinitrogen pentaoxide is utilized, 4 moles of nitrogen dioxide is produced. Meanwhile, only 1 mole of oxygen is produced. So, the rate of production of nitrogen dioxide is greater than that of oxygen. So, then it should have the higher steepness in the curve than that of oxygen. I guess that it is clear to you all. Right? So, that is how I represent this formation of nitrogen dioxide and oxygen, and then the how it decrease the concentration of dinitrogen pentaoxide. This curve will be given in my notes. It will be there in the WhatsApp group. Right. Next one that I am going to discuss is respected to this thing. I can write expression for the rate of production of oxygen. I can write expression for the rate of production of nitrogen dioxide, and I can write the expression for the rate of decomposition of dinitrogen pentaoxide. So when I write an expression for the rate of production of oxygen in this one, right? So the rate of production of oxygen, we can write it like this. Okay, how we say that rate of production of oxygen? We can write this rate of production of oxygen. Right, rate of production of oxygen is equal to what? Delta concentration of oxygen gas, right? Concentration of oxygen gas, O2 gas, right? Divided by delta T. That is the expression for the rate of production of oxygen gas. Similarly, I can write expression for the rate of production of the other one is nitrogen dioxide gas. That is also change of nitrogen dioxide gas concentration per a given time delta T. Right, then now you can understand that I wrote an expression for the rate of production of oxygen and the rate of production of nitrogen dioxide. Now I am going to write the expression for the rate of decomposition of dinitrogen pentaoxide. So we can write rate of decomposition of dinitrogen pentaoxide is equal minus delta N2O5 gas divided by delta T, means time taken. Right, you know why this is negative? This is negative because dinitrogen pentaoxide is always decreasing when the reaction proceeds. Why these two are positive? Because oxygen and nitrogen dioxide gases are produced in the reaction. Right, so now we will stop the second video.